All right, guys, today we are talking about labs. So before we go into this whole lab section, I want to talk a little bit about scientists. What do scientists do? And to me, what scientists do is they predict the future. For example, if we're talking about like a solar eclipse, scientists know exactly when a solar eclipse is going to happen. Let's say like in New York or something. They know exactly when it's going to happen to the second. And how do they know those things? How can they predict that future? They have the data. They have the data of the different planets going around, the different stars that are around. They have all this data. They make calculations, and they know from that data and their understanding of the universe, they're able to calculate exactly when that solar eclipse is able to happen. They're able to predict the future. If we're talking about chemistry, science again, we have two different mixtures. They know when these two things mix at the exact amount of drop or milliliters, when this mixture goes into this mixture, it will change colors. They know exactly when that's going to happen, the amount that's needed in order for that reaction to happen. And to me, that's what science do. Science predicts the future. When they know the data, when they collect the data, and they know the principles of the universe, they're able to predict the future. And when I do labs, that's one of the main labs, the third lab that I really try to do. I try to have students predict the future, to be real scientists. Okay, so I'm going to be talking about 3 different labs that I do. The first kind of lab that I do is inquiry-based labs. And what this is primarily doing is this is discovering. And I do these kind of labs at the beginning of a chapter or right before a chapter starts. I'm just trying to have them understand and discover things for themselves. So for example, when I'm doing free fall, I'll grab a golf ball or any kind of a ball and I'll just drop it. And my question is, when that ball fell, did it fall at a constant rate, at a constant speed? Or did that ball fall accelerating? Meaning, was it getting faster and faster as it fell? And I'll drop it a few times and I'm like, all right, guys, go figure it out. Get whatever you need from the class and go figure it out. They're discovering this for themselves. They don't know what the answer is. They don't know exactly how to do it, but they're discovering this for themselves. With inquiry-based labs, I do a lot of simulations. I do a lot of simulations for them to be able to discover these things on their own. I have a simulation with forces, that when a cart is getting pushed with a certain amount of force, is it moving with a certain speed, or is it accelerating the whole time when there's no friction? What's going to happen to it? And when there's no force on it, when someone lets go of it and there's no friction, is it going to keep going at a constant rate, or is it going to start to slow down? I have them discover these things on their own. When we're doing things like projectile motion, they have simulations. I have them maybe at what angle is something going to be launched that goes the furthest amount when you're throwing it from the ground. And the angle is like 30 degrees, 60 degrees, and they try different angles. At what angle is it going to be the most amount of distance that it's going to cover? And all of these different kind of things, a lot of times I use simulations for these inquiry-based labs. The second type of lab that I do is just purely fun labs. As a high school teacher, I see my primary goal is to inspire these students, to have them think of physics as something fun, as something really cool, of something exciting. I know most of them aren't going to be physicists or go into anything related to physics, but I want them to have a good feeling associated when it comes to physics. So a lot of times we'll be doing things, and this is important. Like for example, we'll have like a push-up contest when we're learning about work and energy and power. And people are doing like push-ups, they're calculating how many calories they're burning through this. We'll be like running up and down stairs. And we're not predicting anything. We're not really discovering anything. But we are having a lot of fun. We're collecting data. We're writing different things. We're doing different equations. But we're primarily having fun. The whole class is having fun. When we're learning about graphs, we go outside and we set up cones and we graph like how fast somebody goes and how it looks linearly and how the slope looks. But they're running, they're hopping, they're crawling, they're acting like a penguin, and we're analyzing these different graphs. But a lot of it, we're just having lots of fun while we're doing it. I don't do these labs so much, but ever so often, I try to sprinkle in just like fun, having them associate physics with just good feelings and things like that. The last kind of labs that I do, and my favorite, kind of what I alluded to at the beginning, is predicting the future. And I remember one student coming up to me after we had this lab where we had like a marble, and the marble rolls down the ramp, rolls on the table, and then falls into the cup off the table. And they had to predict, where is that marble going to land? They had to like put like a cup or something, a target there of where that marble is going to go. They calculated all the data, they collected all the data, they calculated everything they knew, they measured all the heights and different things like that. And then this student had the ball go, really scared because their grade depended on this. And then it hits and it goes inside the cup. And they're like, wow, I feel like a magician. I feel like what I did was magic, but it's science. And I'm like, yeah, that's what science is. Well, that's what a scientist is. They predict the future. They are the modern day magician or witch or whatever. They're able to know what's going to happen before it happens. And those are the type of labs that I love to do. Like, for example, that hit the target lab is something that I love to do. But other kinds of labs that I like to do, is like, here's a ball, here's a stopwatch. Go figure out how tall that ceiling is. No one knows what the height of the ceiling is. They don't have a measuring tape or anything like that. But using their knowledge of free fall and gravity, they're able to predict and know what that height of that ceiling is to a good degree. And we have different things like this where what they're doing is predicting the future. Another thing that I love to do is like having like an unknown mass. So like, oh, we don't know what this mass is, but it's on a pulley system. And because it's on this pulley system and we know how long it's going to take this unknown mass to hit the ground, using our knowledge, let's figure out what this unknown mass should be. And we're predicting it before we know what it is. And then we put it on the scale and it's something very close to what we calculated. And those are my favorite kinds of labs. Being able to actually be scientists, being able to predict the future, being able to know something before it is measured, before it happens. And those are the main kind of labs I try to do with my students. And those are my favorite kind of labs that I try to do with my students. So again, inquiry-based, I usually try to do that before the chapter or right at the beginning of the chapter. Fun-based, sprinkle that in once in a while. And 3, the one I try to do the most is predicting the future kind of labs, having them act like real scientists. Love to hear if there are any other types of labs that you guys do and your thoughts on these types of labs. Thanks for watching, guys.